Okay, so we're going to talk a little bit about one-sided limits here. Let's recall before we jump this. If I go and let's just say I do this. Okay, so we've got the limit of the function x squared of x goes to 2. So this is the limit we've talked about the last couple of sections. Okay, what does this mean again, right? So I'm going to call this L. Hopefully you may have some sense of it, but this is the number that f of x as x squared approaches as x approaches 2, and I'm going to say, but we never consider x at 2. So remember again with the limit is I really care about what's going on to the function right close to the point 2, but not at the point 2. All right. And hopefully you can get some sense about it, that that's actually going to be 4. Okay. So let me change a few of the things here. So I'm going to do a general lim x goes to c plus f of x equals L. All right. And this again is the key difference to the previous one. Okay, notice this, I'm not saying x is plus c, like plus 2 or whatever. I'm saying it's a superscript on that. So basically what this is the number that f of x as x approaches c for x greater than c. So when we say plus, we're on the positive side of c, so x is greater than c. Okay. This is called the right-hand limit. And I'll write down the same thing for left-handed in just a bit. I'm going to give you a little bit more light, make it a little bit better to see. Okay. Let's look at an example. So let's say I have a function that looks like, let's do 1, 2, it's like this. No, let's get rid of that one. Sorry, my function looks like that. And let's say this is 2, for example. Okay. So if I'm looking for the lim of x goes to 2 on the positive side of f of x, all I care about is numbers bigger than 2. So I'm sort of following, I'm going to follow the function back to 2. I don't care what happens at 2, but it looks like this is 1. Okay. Good. All right. So now here's all I have to do to change some of this. Left-hand limit. This switches to a negative. That switches to that. Okay, so the left-hand limit as x goes to c, to the negative sign. Again, the negative sign is the superscript there, not in front of the c. Function is L. So L is that number that x approaches c, but only for x less than c. So let me just look at this. Lim x goes to 2 negative f of x. Okay. And this is going to be, I'm thinking about 2, but less than 2. So it's this part of the function, and as x goes up there, it's going to be 2. Okay. All right, let's do one other. Okay, so the picture before was again based on the graph, but what we now know with a lot of the limit laws is that we can do these things analytically. So I'm going to find the lim as x goes to, I'm going to say 1 on the plus side of g of x. Okay. And the really nice thing about this is now that I'm doing this, I can look at this, and this is the function on the positive side of 1. So I can do lim x goes to 1 on the positive side of x squared. Okay. And again, remember, this is 1 squared, which is 1. This is the limit law with the power, which I'm not going to look up right now. It's back in the previous section. But maybe I'll just write this as a limit law. Okay. We can do the same thing with the left-hand side, and all I have to do is grab that, okay, and I can get, what I can do is I can do a lim x goes 1 negative of x, lim x goes to 1 negative of 2. I believe this is the addition limit law. I think it was number 3, what we talked about the other day. 1. Again, don't let the negative sign confuse you with the sign. This is just 1 on the left-hand side. So I just plug 1 in there, and I plug 2 in there, and I get 3. Okay, so this was done. This is done analytically with limit laws. Which again, to get really precise, is the right way to do these things. Okay, so you can be asked the question, like if I have a graph and I'm asked to find one-sided limits, you just estimate the best thing from the graph. If you have to build a table, then you do your best from building a table. However, when you're really trying to get this stuff done, you really need to use the limit laws, or we're going to see in the next section continuity, to find these things very, very precisely instead of just estimates.